and welcome to FinextraTV. I'm Hannah Wallace, and today I'm kindly joined by Hancell, Manager of Global Fraud Consulting at OneSpan. Hello Greg, thank you very much for joining us today.
Thank you, Hannah. It's a pleasure to be here.
We hear a lot of stories about account takeovers and hacking as well. How can financial institutions get better at detecting and mitigating these attacks?
So there's three areas, I guess, technology, process and people. And the main focus at the moment is on technology, which is really being driven forwards by machine learning.
So machine learning, let's talk a little bit more about that. Could you pinpoint the main areas they're helping mitigate these risks?
Yes. With machine learning, it's two main models that are applied, and that would be supervised machine learning and unsupervised machine learning. With unsupervised machine learning, it's more of an anomaly detection, where it's determining what is usual, what is unusual, whereas with supervised learning, it's been trained on historical information around fraud. So is this event fraud or not? Therefore, it's able to predict a fraud score. So the machine learning model can apply in real time to every event that's occurring a score back, which can therefore allow a solution or a user to take an action based upon that. Also, it has the capability to think in multiple dimensions. And when we think about what is in a dimension, that would be the data elements that you would take, such as a device, such as their IP, internet service provider, and then how they are calculated into what's called features. Features are used inside of a machine learning model. So if we take the example of a device, how is that device used? What is the age of that device? Is that device new to the user? Is it new to the bank? Or is it new to the financial institution? Is it new to the corporation? What security parameters are on that device? What biometric methods and authentication methods are subscribed to that device? What communication method is it using? What model is it? What operating system? Has anything changed? All of these are questions you can ask around the device. Well, what financial institutions are doing is taking this data and asking those questions in real time. And then based upon that, they are modelling that information in a high-dimensional space, which is the capability to model lots of different parameters such as those beyond a human's capability, so into the thousands of dimensions. What that does is it then gives you a likelihood of it being anomalous or a likelihood of fraud in real time. Also, machine learning can be used from an automation perspective as well. It's impossible to have a fraud expert in place 24/7 and seeing all events. It's just not possible. So machine learning is removing that availability bias that we as humans face into, as well as potentially affirmation bias that we see something, it happens, so we put more weight towards that as well. So it's also removing these kinds of challenges and allowing for the capability to take decisions on events in real time in an automated way. So potentially allowing for another type of workflow. One of those workflows, for example, could be what type of authentication you would apply, whether the strength of that authentication relates to the risk, and that can also lend itself well to towards customer experience, whereby you can say, actually, the risk is low, therefore there is no need to request authentication from this user at this point in time. However, if we think about back to continuous monitoring, if that risk changes, well then maybe we would serve up a stronger authentication biometric. So that allows the financial institutions to adapt to the risk by applying machine learning as well.
Really interesting, certainly a space to watch. And while I've got you on the topic of machine learning then, are there any other trends that we should be keeping an eye out for?
Yes, yeah, good point. So yeah, in the future, a big challenge is actually the capability to have explainable machine learning. So what's really important is that you understand what your machine learning model has learnt. Because it's no good if it learns something and you believe it's detecting something, but actually it's learned something incorrect. Right? Yeah. And that could be from a bias perspective. It might be making decisions incorrectly because it's learned something incorrectly, which would be unfair to somebody that maybe might be applying for credit or a loan. But also it would be a risk if it's learnt something incorrect from a fraud perspective. So you need to be able to explain what your machine learning model, first of all, is learning. What is its data set that it's learning upon? Also, of these features I reference, and that is something like the device and so forth, intelligence points. What is the weighting of these that influences your machine learning model? And why that's important is, if you are a fraud analyst, you need to know, what does a score mean? If a score is 90, what does that mean, and why is it 90? And also, how does that relate to a population set as well? So how does that relate to previous events? How many users are above 90 and so forth? So it's explainable in terms of understanding what the score is and how that is determined by different elements that are, brought about to arrive at that score, as well as, of course, the decision-making process as well. On top of that, there needs to be the capability to audit. Machine learning models, there is the capability to apply what we call a champion challenger, which is whereby a model will be in place, scoring, and a new one is spun up, and it will be real-time challenging to see if the new model will outperform the existing model. When it does, it will then come into place and a new challenger will be spun up. Now, that's great because it allows that you have relevant machine learning models that can handle drift and different types of new fraud or changing patterns or spends or products, things like this. The risk is that from an audit perspective, that model could have made a decision. So how does that link back to the customer that is impacted by that at that point in time? So there needs to be an auditability, traceability, as well as an explainability around that.
Well, Greg, you've certainly painted the picture for us, and I think it's safe to say watch this space. But for now, thank you very much for sharing insights. It's been a pleasure.
Thank you. It's been a pleasure. Thank you.